Hello. This lab is actually an introductory activity for the kinematics chapter, which is about rates of reactions. In this lab, make sure to do predictions and follow instructions on the sheet given to you. Everyone's data will be slightly different from one another, so it's alright if yours and your neighbors don't match, but also don't try to rely on your neighboring lab group's answers because they'll be slightly different than your own. For this lab, we're just going to basically need a data sheet and 50 pre-separated paper clips of both red and black. We're going to end up shaking up the bag. This will help to randomize what you're pulling out. For the first part of this lab, we'll be pulling out 2 paper clips at a time. Once you have pulled out 2 paper clips, we have to decide whether or not to clip them together or synthesize them. If the 2 paper clips are opposite in color, clip them together. If not, either the same color, like you can just see here, or you have already grabbed a couple paper clips that are already clipped together, do not combine them. Instead, just put those ones back into the bag. An important thing to know about this lab is that these paper clips actually represent atoms and molecules. So this red paper clip here and the red paper clip here represent individual atoms. But for example, so does the black one. But for example, if you have a red and black chain like this represents a molecule. Basically, if you draw 2 paper clips that are opposite in color like this, you clip them together. Uh, and you throw them back in the bag, and repeat the process. If you draw 2 paper clips that are the same color like that, you just don't clip them together, but put them back in the bag anyways. We're going to wind up just doing this for a whole minute and recording how many A's, B's, and A and B's, and all of them in total you have. For the purposes of this lab, we're actually going to call red A, and black we're going to call B. A and B's are going to be the connected molecules, and then, like I said, you're going to find the total later on. Instead of counting all of these individually, we're just going to tell you that we have 50 reds and 50 blacks. None of these at the beginning should be together, which gives you a total of 100 A's plus B's plus the A and B's. And we're going to do this process for one whole minute. So we pull out 2 here. We have black and black, just throw them back in the bag. Another 2. We have a red and red, just throw them back at the bag. Those do not match. We pull a red and black. Those do match, so we clip them together and throw that match back in the bag. Same thing. You're basically just going to want to do this for one whole minute, and then record the data at the end. So I've recorded the data for the first part here, and I found that I made 6 A and B molecules, which means that I took 6 A's and 6 B's for 44 and 44. Then we add the total to get 94 total atoms and molecules together. We're going to end up just repeating this data for a second minute and for a third minute, but the second minute comes first. So here we go. At the end of the second minute, I found that I had 11 total AB molecules, which meant that I have 39 A's and B's both being equal, and for a total of 89 atoms and molecules. And same thing for part 3. At the end of part 3, I found 13 AB molecules, 37 A and B atoms, for a total of 87 atoms and molecules. Now we move on to part 2, decomposition. For this part, you'll have to go through your bag and make sure that you have joined all paper clips to make 50 AB molecules. Instead of drawing 2 paper clips at a time, we will only be drawing 1. If it is connected, we pull them apart, and if we draw an individual paper clip, we just put it back into the bag and try again. Here are the initial values. You start with 0 A's and B's, and you start with 50 AB molecules, which is a total of 50 atoms and molecules together. Alrighty, so here we go. And we are going to start in 3, 2, 1, go. So we grab a molecule, we separate this, and throw the 2 atoms back into the bag. Again, we draw a molecule. We throw them back in the bag. You're going to be drawing a lot of molecules at the start of this, like this. We just split it and throw the atoms back into the bag. You're going to want to do this for another whole minute. Again, for this is for the second part of the lab. And then again, record all of the data. So yeah. I figured it might be a little repetitive to watch me keep doing that, so I just did it for a minute and recorded. I found that I had 39 total molecules, which meant that I had 11 total atoms for both A and B. The sum of these ends up being 61 atoms and molecules, so this will be for the first minute. You want to repeat this for a second and third minute, again, just like the first time, and just remember to record the data each time. For the second minute, we ended up getting 31 AB molecules, which meant that we had 19 A's and 19 B atoms. This totals up to 69 atoms and molecules. Uh, and we did the same thing for the third minute, ending with 26 AB molecules, which meant that we had 24 A and B atoms for a total of 74 atoms and molecules. Having completed all 3 minutes for both trials, you're going to want to start to analyze the data and compare your results to the predictions that you made earlier on in this lab activity, whatever you want to call it. And from this point on, you should actually be done. You completed all your data collection, and just make sure to, like I said, analyze the predictions. For any remote learners or anyone who needs the data, here is the data that I collected. Again, you don't want to copy it necessarily, but it is yours to use if you messed up the whole thing. It doesn't matter too much either way, but trying to get some sort of uh, data and seeing the correlation between each number will be important for later in this kinematics chapter. So yeah, now you should be good. I hope this helps. This is my first one, so if there was something wrong with it or anything, please let Mr. Koenig know, and he'll get the information to me so that I can hopefully try to make these better and improve them later on for future labs and activities.